Howdy, everybody in YouTube land. I want to do something a little bit different. Make this kind of like a backwards video, starting from the work in progress back to a complete machine instead of the other way around. So, what we have in front of me is another recapper's delight. So, I'm in the process of replacing some capacitors here, and really it's the low ESR ones that go, but this one's, let's see. That is a 220 microfarad, 25 volt, and you can kind of see the goo oozing out of it. Just getting started, like just. So all three of them are out now, and yet another weekend, yet another recapping job. So might as well get this done. Also, the expansion bus on this machine is 100% proprietary. And I've been in the process of trying to reverse engineer that because I'd like to make an expansion card for this machine. So here's the motherboard of the machine, and it looks like this motherboard is made by Sotec in Japan. So we have three proprietary ICs with absolutely no data on them whatsoever, so they're mystery chips. We have the EMI 386SX BIOS with its processor right next to that, at least that's standard. We have a DC-DC converter here and another one up here, along with some caps that we need to take a closer look at. And then we have this SPC 8000 VGA controller, which there's some information on, but I can't find anything more than a data brief. So, and then there's that proprietary expansion bus. So it would have been kind of cool to have like an IDE to XT or something in here, or XT to IDE, but I can't because I don't know the pinout of the expansion bus. I was able to get some of it by comparing against the IDE connector as well as these ROMs, but there's a lot of it I can't get because they go into these mystery chips, so I don't know. So I'll have to take a look at that a little later. It may or may not be part of this video. I don't know because there's too much work I have to do to reverse engineer it. And then the third thing is this connector right here, which is some proprietary DC jack. So we have to work with that too, unfortunately. I have a plan with that. The battery chemistry is unknown. It's not labeled, but based on its heft, it's probably lead acid. So I can make some reasonable assumptions that the voltage on the input side, unless this power supply is also a boost converter, I don't see that being the case. It's probably a buck converter, and those batteries need 3.8 or 13.8 to 14.4 to charge. So we know the input voltage has to be minimum of that. I'm going to say a round number, probably 15, anywhere between 15 to 20 volts. The input capacitor is a 35 volt cap. So it's possible this takes a 20 to 25 volt input. I don't know. We're going to be guessing on that front, because I do not have the AC adapter for this, nor can I find data on it. Just like this machine is very rare. It doesn't really exist hardly. There's probably only a few out there. Anyway, so backwards video, we're starting off with the recap, and then we're going to work backwards and put it together. Oh, one more thing. The hard drive is an Alps brand drive, and I've never seen such a thing before, and it's serial number 1055. So alright, let's get some caps in here. I got some of them on hand. I don't have all of them, but we'll do what we can. I picked this machine up from a Discord user, a very generous one, and I got it for a reasonable price. So I think it was worth putting a little bit of effort into it anyways. Alright, we have the 4 caps in here replaced. There's 2 over here and 1 in there. So there's 7 of them that had to be replaced on this particular DC converter module. This plugs into the motherboard. You'll see that in a bit. So as far as the caps themselves, some of them, like that one's leaking right here around this pin. That one's gone. Let's see, this one is just same thing. It's around the positive pins that they're leaking. So that one's leaking around the positive pin too. Let's see, this one, not so bad. That one I don't see anything yet, but you know. Let's see, these, that one's looks like it's leaking around the negative pin. And then this one, can't really tell, doesn't look like it. Yep, same thing. That one looks okay, but they all had to go, so they've all been replaced. Now we got to solder this back on because there's 3 points at which this board just solders in place. So we're going to mount that back on, and then we're going to replace what we can on the motherboard. But I do not have all of the capacitors for that board, unfortunately. For the motherboard, we have these low profile capacitors, and those are getting harder and harder to get, which is why I said I don't have any right now. I have a few left. I bought some before they went EOL, but none of them are this value, so I don't have that one. I'm going to spot check a couple of them and see if they're still good or not. But I do have these, which are a tiny bit taller. I got to see if they'll clear, so I want to replace those. Then on these, I might be able to get away with putting regular ones in and laying them down. So I want to try that for those. But these 220s, I also have that one too, but these 220s at 10 volt, I do not have them, and they're very hard to get. So I need to make a determination. I'm probably going to take this and pull 1 or 2 of these out and do a spot check and see. Now, I'm trying to think, the reason why these are low profile is because the keyboard literally sits right here. So they can't stick up too far. And then there's a plate that goes over this too, which covers all of this. I got to make sure I can clear that. And if not, well, yeah. Anyways, there's a door that covers the RAM upgrades. This didn't come with any RAM, so it's going to be the base memory that's on here, and I think that's video memory. But so the door that covers this is like right here. So this door where the keyboard sits kind of goes like here. So you can imagine why these have clearance issues, because if that has to sit there, then you can't. Yeah, so anyways, probably not going to be able to do anything with those right now. I'll check them, but probably not. But I can do something with these at least, so that's what we're going to do. Got these 2 replaced. They're sitting a little taller than the originals. We'll have to see if it clears. I checked these 2 and they're fine. They didn't show any leakage and they test okay, so I put those back in, and I don't have them right now anyways. I spot checked randomly one of these, the same deal. Then I get to over here, and out of these 4, I didn't really see anything. Maybe some signs of a little bit, but I can't really tell. So they might be all right, but since those are low ESR anyways because of this, I changed them, and this is jank as hell. I mean, I don't really like doing it this way, but that's the only things I have, and they're getting harder to get those. So I just went ahead and I ran out of my red Worth brand, so I grabbed a couple of these niche icons and threw them in there. You're not going to see them anyway, but I really don't like it. I changed this one as well. So I'm gone about as far as I can with this at the moment because I can't get the rest of the caps right this minute. I'll try, but because they need to be done. Next thing on this list is dealing with this DC jack, because I do not know what connector that is or what standard that is, so I don't know where to find one. Also, the backplane connector, like I said earlier, I don't know what style connector that is either, and if someone knows, please comment, because I need to know what this is, because I want to make a breakout board and possibly reverse engineer this some more. I've gotten pretty close. I've gotten the first 8 data bits and address from A0 all the way up to A19, but 20, 21, 22, and 23 I don't have because they come out of this chip. And there's the control signals like memory read, memory write, the data transfer acknowledge bits for the DMA and IRQs, and there's a handful of stuff I don't know what they are yet. I can probably get D8 through D15. I don't know what they are yet either, and I might be able to do that if, well, maybe if I, huh? I'm not sure how to do that just yet. It's possible I can add my own ROMs in here that are just nothing but no operation instructions filled all the way through. So the CPU will just literally walk the bus until it gets to the end and dies. Then I can logic analyze and probe that. I can also do that on a board that I know what the ISA slot is and look for the same signals and do some compare and contrast, and so I can possibly get some of these signals, but you're still not going to know what the IRQs are. And the interrupt controller is in one of these 3 chips. So because on a 386 CPU you have the int R pin, and the bus is driven with the interrupt vector. So IRQ 0, 1, 2, blah, blah, blah is driven from the programmable interrupt controller. So I can possibly toggle IRQ lines and see what happens over here, but I don't know what IRQ they are, because the CPU has to boot up to a certain point to determine, to program the interrupt controller. The other thing I could possibly do is write a custom program and set up my own interrupt vector tables and possibly dump something on the screen. Oh, I hit IRQ 5 or I hit IRQ 6. I don't know. Yeah, it's going to be an involved process, but for now, I'm going to leave that alone. But yeah, I got to figure this out. And where I'm at with that is this is positive and this is negative, and I could figure that out because they go right to this cap, and you can pretty much tell, one cap leads negative and one's positive, so you figure out which one's positive and negative. But then there's this pin. This third pin goes through that filter network, and then if you look in the circuitry, there's a this is a 6-layer board. So the layer number 2 comes out of this black line and goes up through this via, comes out of that via over here into this resistor and into Q14. Well, this is a network that feeds positive. Once this line goes high, it feeds positive voltage out through this guy here. Well, that guy goes all the way up to this third pin over. Well, that third pin over, this plugs in there. So third pin over comes around and goes into this yellow wire, which comes up to pin this third pin over on this guy, which comes around. You can see that trace coming out and going up and around, and it's going into the logic of this board somewhere. So this pin clearly controls the power supply. What I don't know is if this pin turns the machine on, or if this pin tells it whether it's going to charge the battery or not. So if it's time to charge the battery, it might kick this pin high and up this voltage. I don't know how that works. I don't have the original charger. Plus, there's already a power switch on this side here, but that might be soft power. So, yeah, for now, I think I'm just going to run a red and a black and a green wire and just stick it out the side so I can do some experimentation if we can get this board to fire up. So, we got to put this thing back together because I've gone as far as I can at this point. So, maybe we need to check the screen out. But for now, yeah, I got to get this thing put back together. This is a painful design, how this is made, but this is where that little power supply card goes, is in there. And you got to kind of finagle that into the... Anyways, so the next thing we need to do is we need to get this screen apart because I need to figure out what landmines lie within. Figure out if the inverter, what caps we have in there we got to deal with. Also, the screen itself. This is a monochrome screen as far as I know. I've never seen this power on yet. But we need to check the screen for leaking surface mount caps because, yeah, it's getting to the point to where recapping this stuff is going to be the death of me. So let's get this screen apart. Pulling out those 2 little plastic covers, which are over here, and these 2 screws, this thing literally snaps apart. But these want to lock into place and not want to move anywhere, so trying to figure out how. Yeah, this mechanism's kind of weird. It won't move unless these are down. Anyways, so first glance, we have the screen, which is kind of neat how this is set up. I don't see any damage in the screen, as far as I can tell. Also, I'm looking at the inverter board, and we've got one cap I see right away. Uh-huh. You can just see the green crusty starting. So that's got to be replaced. That one probably does too. So we know we have at least two. What's this one? This one is a 16 volt 1000 microfarad. I have those on hand. Pretty long leads. Don't know if it needs replaced or not, but I probably have it. So the next thing is I got to do is remove this screen so we can check in the screen, because I've not seen one like this before. So yeah, that will not move. No, it does. So this is clearly gravity fed. Wow. Well, let's hope they don't have to ever use this thing in space, because that would be a problem. Anyways, let's get the screen out. Typical of Japanese electronics at the time, this thing was over-engineered to a fault. So trying to get this thing apart is an absolute pain. So I had to loosen those up, which loosened that, and got the cable loose, because I had to get that unplugged so I could lift the screen out, because there's a metal cover on the back and you can't get to the connector. That is going in there, and that's soldered straight to that board. So I'm sitting here like, why? Alright, so it looks like I gotta take that off, because it's impossible to get this thing apart while it's in here. Well, I wouldn't say impossible, but oh, okay, well, let's keep going. I got it extracted, but man, that was painful. So this was all wrapped up in there too, pinned between these two screw posts. So I had to pull that out. And I don't even know. Anyways, I'll deal with that later. So now that I got that out of the way, I want to get the inverter out and then get this plastic thing out of the way. Now that we got the rear cover off, we can quickly tell that it's an Epson display, which makes sense because the chipset for the graphics card is also made by Epson. So they went completely with Epson here. But looky what we have here. Now that guy. And then have one over here, but I don't know if there's anything under this tape. So no, but we got two here at least. Of course, it's these stupid low profile ones. It's important because the back cover literally goes right there. So I need to see if I even have those. I may not. What else I don't know is if the screen's still good anymore. So it's kind of really hard to tell. What I can do though, before I get too carried away, because there's the silicon for the buffers. They're right here. The dies are just mounted directly on the flat flex cable. I don't know if they're still holding up after all these years. I don't see how they wouldn't be, but you never know. This display is definitely over-engineered. Typical of the time. So I have two right away that need changed. What the hell are they? I don't even know. Can't even tell. 3.3 microfarad at 50 volts. No way I have those. No way. I don't think they need to be 50 volts, but yeah. Alright, well, that's what I need. I gotta see if I have them. But I definitely need these for sure, because see, that is starting to leak out of its bunghole. See the green crustiness right there. So what value? Let's see. This one's a Mitsubishi. They're both Matsushita caps. Let's see. 47 mic, 35 volt. I might have that. Maybe. Let's see. I need to lift that up. Figure out what that is. see, 100 microfarad is 16. I definitely have those. I got them over here. So I can replace that one. It's kind of like bodged in there. Holy crap, it's like bodged city. So yeah, I gotta replace that one and that one. Is that one leaking out of its bunghole yet too? Can't tell because I can't get underneath it. Maybe not. I gotta see what I have on hand. But the fact that, whoa, look at that. Bad solder joint central. Wow. That's a problem. How's the rest of them look? Not bad. Maybe a couple of dodgy ones, but that one up there is definitely a problem. So the fact that that is and that's the main filter too. Let's see. The fact that that is a 35 volt cap has me more suspicious that this thing is greater than 25 volt input. Huh. There's probably a 24 volt input. I bet somewhere between 20 to 24 volts on the input. If I were to hazard a guess. Alright, well, let's keep going. Unfortunately, I do not have those particular caps, but what I do have is I have a 2.2 at 50 and I have one at 50, so I can put these in parallel and get a 3.2, which is close enough for government work when it comes to this anyway, so that's what we're going to do. Got the capacitors all paralleled up in there. It's jank as fuck, but I don't really care. This doesn't belong to a customer or anything. I wouldn't do that with a customer. This one's purely mine, so I can get away with doing things like that. Doesn't mean that you should, but I can. So I got those in there now, so that should be fixed at this point, so I can put this guy back together, because those are the only two that I saw in there. Were they leaking? No, I couldn't tell, but changed them anyways. Oakley dokley. We have that capacitor replaced now, and it's put back in there. I even used the original heat shrink that was on there. And the inverter board, I have them both changed out. This one's a little bigger than the original, so hopefully it fits in there properly, but that's good. I got the back of it resoldered where the bad solder joints were. And that one's been replaced, and the two caps and the screen have been replaced. So we should be able to get this thing back together. Although I'm contemplating on seeing if we can't fire the motherboard up first before we start putting it all back together. I'm seriously considering that, because I wonder, because if there's still an issue, there's no sense in putting it all back together just to tear it all back apart again. So let's see if we can get the motherboard to post. If we can get the motherboard to post, then we can get it all back together. So let's do that. Alright, just got everything connected. Got the power supply module back in there. Just connected those guys. So now at this point, it's literally, I need to make sure I'm set right up here, because I don't know. Hold on, let me do that first. 6.7, 12. I'm going to start with 12 volts, because I don't know what's going to happen. Alright. Nothing. Let me try this switch. Oh, I'm drawing current. Whoa. There we go. It works. SoTech. 2 megabytes of RAM. 1987. CMOS display type mismatch. Run setup utility. Hey, no lines, no dead pixels. It turns on. Now, I don't know what this does. I haven't connected it to anything. What if I ground it? Doesn't really do anything if I ground it. It may control battery charging. I don't know. But hey, we got somewhere. I like that. So now I think we can safely put this thing back together. Just missed it on camera, but right as I was stopping the video, I heard a pop, and it turns out the 100 microfarad capacitor, or 47 microfarad, or whatever it was, 35 volt cap, I put in there backwards. So it went boom. Yeah. Anyway, so now I got that fixed. I got the bezel back in there, the 2 screws in, snapped it on. So now I think it's time to start putting this guy back together. Now that that is done, we got to start putting this machine back together. So since you're seeing this video in reverse, I didn't actually intended it to be that way, but I thought it would be fun because, anyways, this is the bottom cover of the machine. And this machine is made, well, it says it's CompuAdd, but really, this machine is manufactured by Sotec, which is who these guys are. Now, if I'm not mistaken, I could be wrong, but if I'm not mistaken, Sotec is the same company that manufactured the e-machines that got sued, that looked like the iMac. I think it's the same company, but this is all Japanese made, so I figured, why not? It's kind of a cool machine, and thanks to that Discord member that found it in e-waste and sold it on to me very cheap, I'm thankful for that. But anyway, so let's go ahead and get this motherboard repositioned back in place. I've got to remember where the screws go in. Yeah, so I gotta feed these. I'm gonna leave these wires out because, again, I don't know yet. Whatever, I don't care enough. This machine is, you know, a cool machine, but I do not have the DC jack, so, or the DC adapter, so I could put a barrel connector there, a standard one, but there's still the mystery of this. I need to figure out what this does, and the best way to do that is this here. Now, I got to take this thing apart in the future again anyway because I need to finish reverse engineering that socket. But because of the upcoming move, I'm trying to wrap up all these half-taken apart projects and getting them off my desk. So let's start getting this thing back together. I might throw some RAM in here too. We'll see. So let's go ahead and start putting the board back in. I've got to remember how this board goes back in. So that will just go there. And I also have to remember which stuff went where. Yeah, it's not want to go in. I need both hands. So to put this thing back together, we've got to grab all our little standoffs we have over here. We have a pile of them. And because I didn't show it being taken apart. And then there's these metal tabs. Well, these metal tabs, there's 3 of them, and they go back here like this. Or maybe they're like that. Let me look for marks, screw marks. Okay, it goes in there like that. So that is going to be how we put this together. So there's 1, and then there's 2, and then there's 3. So let's go ahead and get those back in first, and then we're going to get all the screws in the correct proper way. And then we need to service the floppy drive. Next thing I want to do, now that I got all that screwed down, is I want to get to the floppy drive, and I want to inspect it and see if the lubrication, what it needs there, if it's using belts. Because I tell you what, belted floppy drives are the bane of my existence right now, because belted floppy drives have a special place in hell, in my opinion, because it's painful to try to get them working again. So who made that? Epson, another Epson product. Yeah, surprised they didn't use Sony or anything like that. That's another Epson product. So even though this computer is made by Sotec, they used Epson components. Anyways, ramble. Alright, let's get this drive apart in the hope that we don't have a belt or anything obscene like that. And if not, what we can do is just replace or, you know, lubricate and clean the heads and all that fun stuff. So I think that's what we're going to do here. Typical maintenance. Nothing special, just routine maintenance. That not, you know, the 30-year maintenance period. It's a very skinny drive. It's almost like a laptop drive, but it is not a laptop drive. Alright, so at this point I gotta peel the rear tape off. Yeah, I think. Well, it's coming out. Alright. That's been removed. Oh, we got a cap here. Let's see, what are you? Don't see any leakage. But yeah, I gotta get this apart and I need both hands. So I got the cable and the lid and all that stuff off, and that one capacitor is part of the cable. It's just kind of like in there. It took the label off with it, unfortunately. But yeah. So, pretty thick cable. Anyway, so I got the lid off, everything off of it, and no belt drive. This is direct drive, thank the Lord. But we've got a couple of capacitors in here. And what I want to do is I want to check those and make sure there are any signs of leakage. I'm not seeing any. So what value are they? 120 microfarad. Yeah, I ain't going to have that. Why such an oddball value? What is this one? 50 volt. 10? 100? 101? 10. So that's a 10 microfarad at 50 volt. I think I have that one. That one I'm not going to have. No, that's a weird. So Epson SMD 1000. That is a weird value. Huh. Alright, well, I'm going to check my stash and see if I have those. I know I don't have that one, but I wonder if a 100 would work there. There's got to be a reason why they're using a 120, though. I'll check and see what I got. If I have them, I'll change them. And then I'm going to lubricate the worm drive gear for the head and then the guide rails and all that stuff so we can get this thing ready for use. Alright, so I took the bottom cover off so I can get to those caps, and guess what? They're in this. You can't remove this board unless you remove everything else on top of it, so screw that. What I did do, though, is I cut this plastic away that went there, so now I should be able to get the caps, because luckily they are there and there, so I should be able to get to them. We'll see, though. So I was able to remove the cap, and look at that. See, you gotta check everywhere in these machines. Now look at that. This is shot. That was never going to work right. So yeah, when you're working on these old machines, you got to replace the caps on everything. Alright, so I have these two capacitors installed, and they do clear. They're a little taller than I want them to be, but not a whole lot I can do about that. They do clear. So now I can finally get some lubrication on probably this rail here. Just a couple little drops of oil. Work down there, and then I want to do a little drop of oil in there and work that in, and possibly a little drop of oil on this drive gear. Clean the heads, and that should be good. Got everything else lubricated, and I got the head clean. There's my old Q-tip over there. And I replaced this capacitor as well, sitting on top. I didn't see any leakage, but I replaced it anyways. And the old one, as I was pulling it out, just kind of like disintegrated, where this stuck in that stupid glue. So the wrapping came off, and I had to figure out what its value was. Anyways, so that's done. The second cap was okay. This one was definitely leaking. That was the original 100 or 120 microfarad. I replaced it with a 100. That's all I had on hand. So we'll see how that works. We'll get it in the machine and get it all mounted up. Now, before I put the hard drive back in, I want to take this board out and make sure there's nothing sneakily hiding under there, aka capacitors. Anyways, so I really hope this is good, because since there's no putting an XT to IDE in here, because there's no pin out of that. So this is the back point, or this is the thing where you would slide the card in. So yeah, I don't have the pinouts to that. Unfortunately, I do not. So let's see, this would go here underneath the hard drive. So this is literally the expansion connector. So the card would just plug in here. So this is your space. Now, unfortunately, like I said, I do not have I don't know what connector type that is, and I don't have the pinout. I'm not sure how to get it either, because these 3 chips are more custom chips. So between the IDE connector and that, I was able to get enough, but it's still not, yeah, it's IDE, and you can put an IDE drive in here. The trouble is the BIOS is going to be so old, it's only going to recognize certain ones of these drives. So if you put, say, an IDE SD card adapter in there, chances are the BIOS is not going to recognize it. It won't recognize the full capacity, at least not until a drive overlay software is loaded. But yeah, I'm going to go ahead. I got the floppy drive mounted in there. I'm going to go ahead and check the motherboard out on this hard drive and see what we got before we put it back in here. Survey says of course. Of course. Why wouldn't there be? Ah! Oh well. Well. Yeah. They're going to have to be replaced. Luckily, I should have those on hand. I think I do anyways. So let's do it. Let's replace them. I got some solid caps I'm going to use. And looky here. Yep. Peeing all over the board. Of course. So yep, they got to go. And just like that, they've all been replaced with solid ceramic capacitors. This is just on the power inputs anyway, so not a big deal. It's just there for filtering. So that's now done. I had to clean up all the goo that was left behind. So I don't even know if the drive works. There could be a broken trace there or something. Who knows? But we shall find out. So let's get it back together and we'll get it installed back into the unit. Now, this hard drive is mounted in somewhat of a sarcophagus. It's kind of crazy. But, so the drive has got some interesting jumpers here. I've not seen that before. But anyways, you can see the guide rails where the expansion card would normally go. But anyway, so what we have to do is we have to get it mounted into the carriage first, which is 2 screws here on this side, 2 on this side, traditional hard drive screws. So that will go in like so. But before we can, we actually have to connect these cables into this drive and then set it in. So let's do that. Alright, cables are mounted in, so let's get the drive centered in and secured. Okay, everything's lined up best we possibly can. Okay, so let's put in our, trying to think, how does this, okay, expansion connector. It goes in like this, but before it can, we have to mount this screw in. Oh, come on. Alright, so that's now screwed in. So the next part, I need both hands. There's a standoff where the screw goes all the way through. So that sits here. And then this screw goes through this board and this at the same time. They actually made it somewhat easy and made this a hook so you could just get it started. And then carefully slide this in here. And not be able to slide it in there because you can't. You can't. Wow, why would they do that? Why would they design something that stupid? Alright, I'll be back. And with that, we are in. So that's all tight now, and it's got the standoff under there, so this drive's not going anywhere. It doesn't, it kind of mounts in on the rear, but the next thing we have to do is now we have to get this guy installed. And the way that works is we have to hook you in like this. Pretty sure. Or something like that. Maybe it goes like this. That doesn't make sense because you can't. Alright, it's been a while since I've done this, so pretty sure that goes around. Yeah, I need both hands. So it slides in this way and it sits in between the two, so now we're in place. I told you it was like a sarcophagus. Now I've got to put the screws in, which are right over here. So we're going to take this guy and we're going to thread the needle here. Yeah, I'm going to lose that. I need both hands. Tripods would be helpful here. So that is now installed. What I don't remember is where this guy went. I don't know if that went here or I'm not sure. Let's see, there's a mark. It's a big ding right there. Where did you go? I don't know if you went there or if you went this way or maybe you went that way. Actually, I think you went that way. That's right, it goes this way because the power supply bumps up against this. So yeah, that makes sense because you can see the two bump marks. And then right in front of those bump marks are these guys. So that would have bumped into that. Alright, well now I got to put that in. That's going to be fun to install. Yeah, alright, well, let's figure that out next. I had to take the hard drive back loose again because that won't fit in until it is. So yeah, this is, what a dumb design. I mean, seriously. Alright, that's all back in there. So this, I think this is an insulator. I think. I don't know. But that goes in, but you can see where the bumps were. So see that little ground bump there? That kind of lines up with there. So that's where it went. It's been a while since I've had this apart. I'm just now getting to making videos on it. Alright, so let's get that guy into place, which is fun to do single-handedly. Alright, pause. Alright, now it's in there. I just got to add, this is the original tape here, but it's kind of lost its sticky. So I'm going to just get some mailing tape and add to that. Just put it right there. What's fun is going to be getting the battery connector plugged in right here. Cause yeah, I got to figure that one out. All right, well that's not important at the moment. Let's start getting this together some more, and hopefully we get it set up right here. So I think this guy's, trying to remember here. Yeah, I think that metal piece has got to go on next. So let's do that. When I took this thing apart, it kind of just came apart on me. So I'm trying to figure out how to put this together. This is a terrible design because now I got to plug that cable in, which sits right there. Hold on, I got a phone call. So I finally was able to get it together. I have the machine just kind of sitting together at this point. I don't really have it, nothing screwed down or whatnot. So the card, the little isolator card that was stuck to the top case actually comes off, and you got to shove it down in here first and then tape it in place. And then this sits on top. That made more sense. So if you saw the previous, I had a phone call, so I couldn't really do any recording, but if you saw the previous 2 slides I inserted in. That's what I had to do. So now we've got this together, and before I fire this thing up completely or get it all put back together, I want to see what the hell this thing's going to do. So let's get connected here. So, alright, does it work? We don't know, but we're going to find out. Where are you, switch? There you are. Drawing current. Hey, there we go. We're back up. Hard drive spun up. Alrighty then, so see, CMOS battery state low. Yeah, well. See, run CMOS setup. See, what's the I don't even know. Primary display. VGA or EGA. Hard disk drive C. Oh, I don't even know. Oh, it's those custom types. I don't know which one it is. It's a 40 megabyte hard drive. Let's just pick up a random 40 megabyte hard drive. Yeah, let's do that. No, actually, I think it's a 42 megabyte hard drive. $42 megabyte. Let's try that. Okay, exit. Yes, I want to save, and it's not going to want to. It's probably not going to save. Just complaining about the CMOS battery. Two megabytes of RAM. Yeah, that's a problem. So we got to fix that. Exit for boot. Yeah, see, there's the type 33. Yeah, it's... Well, there may not be anything on the hard drive, so let's, over here in my stack, I have these on-track things. I don't know if it's gonna do anything, though, but to see if the floppy drive works. It's trying. It's frozen. It's not even... Oh, come on. It's not even indicating that it's going to start anything up. Oh, there it goes. Okay, it's just being a little slow. Let's see if this will detect the hard drive. We'll have to see. So I think this is going to take forever, so I'm going to pause the video while this does its thing. Hey, now we're loading at least. So let's hope that works. Doing some more self-checking. Hey, I think we're starting up now. Oh, yep, there we go. Contrast is too dark. There we go. Oh boy, that's fast. It's reading the disk at least. Oh man. That is some fast video hardware. Alright. See what's it do next. Oh boy, this is going to take a while. Yeah, let me pause this. Now that it's drawn, let's hit the enter button. That one was fast. But it took forever to draw those previous two boxes. Alright, and it was taking forever to draw that one too. Let's see, data diagnostics. Let's just run the diagnostics. See if it picks up the hard drive. Oh, there it is. Alps Electric Co. Ltd. DRR040C. Yeah, that's it. That's all we have. Drive 1 failed. Well, that sucks. It's possible this software's too new for it, but Drive 1, Alps Electric Co. failed the quick functional test. Further testing was aborted. Well, yeah, well, I guess the drive's bad. Or I got the wrong type number. I don't know. I'd hate to leave this video on such a cliffhanger, but I gotta figure out what I'm gonna do about the hard drive. I don't know if this BIOS is gonna see one of those IDE to CF card adapters. I don't know. So I need to come back to this, I think. Yeah, so let's work at this a bit and figure this out, what's going on here. So I went into this program that's the on-track drive overlay software and did a drive query, and in the previous screen it shows my cylinders, sectors, heads, and all that stuff. So I went ahead and put that in the BIOS, and it's custom type 47. Still, there's no hard disk present or anything like that, so yeah, it's just not gonna work. So unfortunately, but here's the problem that I'm having. So because I'm wondering if this is what it is, because if I go set up, F1 exit for boot, shows my custom type 41, but it doesn't work. Now if I reset this thing, and then if I go into the BIOS setup, once it gives me that same error again. So we go into the BIOS setup, it's gone. It's not saving anything. So I'm wondering if that's what our issue is. So cut the power off here. Unhook our power here. Keep everything kosher. I moved that to 15 volts because the battery is 12. And if I run that at 12 volts, I only see 10 volts at the battery. So that's probably what it ran at originally. So here's where we're at. The problem we're having is right here. That DS1287. Unfortunately, that DS1287 contains the CMOS settings. I bet if this is like the IBM PS2 series, I bet if that's dead, no matter if it's still hot or not, it will not hold any settings. So that might be what's causing the problem with the hard drive, possibly, or the drive is bad. If I run, there's a program on that same utility. If I go to the diagnostics and say do a seek test of the drive, it gets to head 10 and then it gives up and says error, seek error. Well, according to the configuration that pulls from the firmware of the drive, it's only 2 heads, not 10. So clearly something's going wrong with the BIOS, and it's probably that. So, oh yeah, this is mechanical. I like the way it types. So yeah, I've got to get in there and pull this chip and redo it. Now there's a website out there, Glitchworks, that sells a replacement 1287, but they're $45, and that was twice what I paid for this machine. So I'm not going to do that. What I'm probably going to do is the age-old trick of dremeling out the sides here, and soldering some wires and hooking up the battery. So unfortunately, what that means is we got to take this thing all the way apart again. But I might be able just to take the top off and this off, leave the board in there, and just Dremel what I need to Dremel to get to the battery. But yeah, it's painful. So that's what we got to do next. Well, that might just be officially the ugliest hack in the world, but it'll do. So let's solder some wires to that and hope we can bring this Dallas back. I cut this in a little more to try to disconnect the battery that's in there, so hopefully we'll do that. I got to look at the diagram again and figure out which one's positive and negative, but that's what we're going to have to do. I do not have a coin cell holder, So temporarily, I think I'm just going to tack this in and just hang it off the side because the keyboard, this ain't going to fit in there with the keyboard, but I can use this to determine if this is going to work properly or not. So let's do that. All right, well, here we go. Yeah, these batteries are old. I don't even know if they're any good. All right, so all right. We got power. Will it save the settings? We're going to find out. Alright. F1. See, run CMOS setup. Alright, let's do... I don't know. And we'll just make this whatever. So we're going to do that. We're going to do that. We're going to save. See if it holds it. Hey, it holds it. Alright, so no error this time. Control Delete. We'll go into the BIOS. Okay, we're going to run setup. Boom. Alright, so let me get the correct information put in, which I don't have it in front of me because it's on my phone that I'm currently on. So let's get that done. So it won't boot. It keeps giving me that missing operating system on the custom type 47. So I'm in the process of going through and figuring out which one of these configurations actually works. See, drive C error, so dang it, so 5 doesn't work. Alright, let's figure out. Going to the BIOS again. Yeah, timer error, what is that? That was new. So you run CMOS setup. Alright, so let's try looking for anything close to 40. That's 49. 20. Let's try 14. Save. See what that does. I also changed the inverted screen too because I got tired of staring at the white. Drive C error. Okay, so that didn't work. This is painful. And it's not like you can find the data on that particular Alps drive either. At least I did some research. Alright, so run, setup. Okay, next one in the line. 40, at least that one's exactly 40, 17, so let's try that one. This is literally a guessing game here. Bypass RAM test. Hey, no error. Oh, it's starting up now. So type 17 seems to work. Oh, we got an error. Okay, so let's see. Program serial number, passcode, record breaker. Why would I want to break records? Definitely not a speed record, that's for sure. I don't know. 1, 2, 3, 4. I don't know what the password is. Well. Okay, so gradebook, attendance student. So this was used in a school, it looks like. Or a teacher's computer. Let's see, 5, I don't know. Select screen colors, definitions, blah, blah, blah. No, I don't care about that. What if I hit escape? Exit. Yeah, I want to exit. I don't care. Okay. RB, record breaker. So there's some class files in there. Dang. I was in elementary. 91, I would have been in kindergarten when that was created. See, what's on the main C, which we listed it earlier. You know, this thing has Windows. Let's see what version of Windows it's running. Oh, Windows 3.0. I didn't expect that. Holy crap, it's got the original install. Wow. Because it has the CompuAdd background. It has the original install of Windows. I definitely want to back that up. Let's see, what version? 3.0. It's running in standard mode. It looks like. With 1.1 megs of RAM available. So yeah, this thing is... Yeah, I don't have a mouse. And since I have no expansion, I only got one serial port, I either have to choose, do I want a mouse or do I want to connect it up to, let's say, you know, a Y modem or something like that. Because, yeah. See, MTG Win. I don't know what that is. Let's run it. Ah, nope. So this must have had a... I don't know, that's weird. Seems to be working. It's been a long time since I've used any of the Windows versions outside of, you know. Let's see, poker. Hey, why don't we play some poker? VP Win. Mask video poker. Jacks are better. So this is like a Vegas type thing. Yeah, that's enough of that. No, I don't want to save. Goodbye. Okay, so that's nice. That works. The hard drive's working. So I think the next move is I want to keep playing around, but there's more class stuff. You know what? I'm gonna kill this. Yeah, goodbye. Let's exit Windows. Does this thing got DOS shell on it? I wonder if it does. It actually does. So yeah, it has DOS shell. Let's see, we got some now that we have a file manager I can actually navigate. Let's see, CM, DOS, GBC, no files, GB demo. I don't know what GB demo is. Gradebook, probably. Oh, well, hey, it's got LapLink. So, you know what? Since it's got LapLink, I can probably use that to save the files. Utilities. What is utilities? It says there's a diag. See, there's VGA. There's some... Those are actual... What is those? What is GSC? I want to run GSC. What does it do? Cannot installed. Good proper English much. Okay. Let's try this 003 down here. Gemini Technology. So this is factory software. I'm wondering if that's been archived. Probably not. Escape. Press any key to return a DOS shell. God, this is bringing back memories. Not good ones either. What is Diag? American Megatrends Diagnostics for model A19 SVT. Or SUT. I wonder if that is the actual SOTEC model number. I might have to look that up. because it might be. So yeah, that's cool. Anyways, I think I'm gonna get something set up here so I can back up the hard drive before I lose it, because we all know how these hard drives can be, especially when they get old. So I want to do that first, and we'll move on from there. But I think, there's some stuff I still have to do. I still have to get the rest of the caps that I don't have. I need to get the coin cell in here, and I want to get it fully put together, but I don't want to do that yet until I get all the stuff in. So I'm at a stopping point. So I think I'm going to end the video here. So here's something amazing. This battery, fifth week of 1990, original battery, 32 years old. This is a 32-year-old battery. All right. Turn the power supply off. That battery is still holding a charge and running this machine. That is absolutely amazing to me. The original battery, 32 years old, works. This is a cool little machine. So anyways, thank you for watching, and if you have a comment, please feel free to leave one. And remember to hit the like and subscribe and all that fun stuff. Until next time, guys.